Hello students, so welcome back to the lecture of some basic concepts of chemistry. Today we will see the part 2 of this theory. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the same. What is our objective? So we will see the characteristics of the three states of matter and try to classify different substances into elements, compounds, and mixtures. If I talk about the previous class, we have seen the development of chemistry and covered the part of mathematical foundation. Now, in this class, we will study mainly about the states of matter, then characteristics of matter, their classification. Next, we will see each of them one by one, starting from pure substance, then their characteristics, their classification. Coming on to matter, we will see mixtures, molecule, and compounds. So there is a whole lot of things to cover today. Let us start and try to cover them one by one. Then if I start with the matter, so we know a very basic definition and it is more than enough to explain it. So anything that has a mass and occupies space is called as matter. So everything that you see around are examples of matter, like your book, pen, pencil, water, air, and all living beings. So they all are the examples of matter, or you can say that they are composed of matter. How you can say that? So by examining their two properties, which are mass and the occupation of space by them. Then further classification of matter is done into solid, liquid, and gas. Now, aside from these three states of matter, there are new states of matter that have been defined in the modern science advent. One of this example is plasma, which is found in the sun. So this is a new state of matter. Okay. If I want to see the constituents of matter, then it can be represented by the figure this. Okay. So this is the solid, this is the liquid, and here is your gas. So in solid, you can see the molecules are very close to each other. The intermolecular interaction is very high. Then in liquid, it is intermediate, and in the gases, it is very less. So they are very less ordered and are moving freely. So if I talk about solid, liquid, and gas, then their particles are in a state of constant motion. This state of motion is more vigorous in gas as compared to liquid, and the less is seen in the solid thing. So in solids, the particles are very close to each other and they are in a orderly fashion. So due to this, the freedom of movement is constrained. Whereas in the liquid, they are close to each other, but they can move around because of a comparable less intermolecular force. Compared to liquids, the gases are much more far apart from each other and their movement is very easy as well as fast. So we can say that solids have a definite volume and a definite shape due to this strong bonding between them, whereas liquid do have a definite volume, but they do not have a different shape because they take the shape of the container in which they are placed. After that, if I talk about gas, they don't have a definite volume nor a definite shape, and they completely occupy the shape in the container in which they are placed. Why it is written completely occupied? So if you go back to the figure in the previous presentation, you would see that the liquid was half filled in the container. You can try, or you would have observed this thing also. But if you keep gas in a container, then gas will occupy the whole container. Okay, as compared to the liquid. And gases do not have a definite volume. So this thing is studied every time. But what is the meaning of this? That liquid have a definite volume and gases don't have a definite volume. So the thing is that if you apply pressure on gases, then initially if it was occupying V volume, then after applying pressure, it is possible that some amount of volume would have been decreased from the container, but still the gas is there. But for the liquid, it is very difficult to do so because they are not compressible, whereas gases are compressible. So liquids and solids both are not compressible. These three states of matter can be interchanged, means they can be converted from one form to another with the application of pressure and temperature. So this is the equation to represent that. If you start heating the solid, you will get liquid. On further heating the liquid, you will get a gas. Whereas doing the reverse thing, that is cooling down, will give you gas to liquid and liquid to solid. This same thing can be done with the help of pressure. So if you apply more and more pressure onto a gas, then gas will finally compressed to liquid, and on higher application of pressure, it can be converted to solid also. So generally, we would see that on heating a solid, we see a liquid form, and on heating the liquid further, we see the vapor or the gas form. Whereas in the reverse process, on cooling a gas, we get liquid. So the very common example would be the visibility of or the accumulation of water droplets on a cold glass, where the environmental water vapor gets condensed onto the glass tumbler due to a lower temperature. Further cooling of the same liquid would give you the solid. Then let us try to classify the matter as mixture and pure substance. So initially we have classified them on the basis of their states. Here we are trying to define them on the basis of their purity. It gives us two components, mixture and pure substance. So let us see the figure to you visualize this classification in a much more broader way. So here is our matter. Matter is being classified to mixtures and pure substance. This mixture is getting classified further to homogeneous mixture and heterogeneous mixture, whereas your pure substances can be classified into elements and compounds. So we will see each of them one by one. So starting from the pure substance. So if all the constituent particles of a substance are same in chemical nature, it is said to be pure substance. Constituent particle means the molecules or I would say the molecules from which it is made all should be identical. Then we call that, okay, it is a pure substance. If each of the molecule or the constituent particles are not same, we have a mixture. So what would be the example of pure substance? So you would take anything like a wood, okay, or a iron. So in iron, every constituent particle is an iron atom, okay. Similarly, if I take suppose milk, then every constituent particle would be same. What about mixture? So mixture can contain two or more pure substance. Suppose we have a sugar solution. It is an example of mixture, but in here the constituent particles are not same. We have two types of constituent particle in milk. If you are taking pure water, then we will have water molecules, that is H2O, and the particles of the sugar. Okay, so two constituent particles can be seen, and this particles can be present in any ratio. This ratio is not defined, and it is totally dependent on the person who is making it or the way it is being made. So we can say that composition of a mixture is variable and not constant. One more thing that has been discussed in the second line is that the pure substance are the one which are forming mixtures, and they are termed as the component of the mixture. So many of the substances present around us are mixtures. Okay, almost all of the things that you see around are mixtures. The pure substance needs to be isolated from that mixture. For example, the sugar solution in water, or the air, which is a mixture of different gases, or the tea, which is a mixture of tea leaves and your milk, water. Okay, so they are all examples of mixture. Then a mixture can be homogeneous and heterogeneous. We have seen the flow chart. So what is the meaning of homogeneous and heterogeneous? So in homogeneous, we have a mixture which is having the same composition throughout the mixture, okay, throughout the matter. Whereas in heterogeneous, the composition of the constituent particles are not same throughout the matter. Why it is so? Because in homogeneous mixture, the components mix very comfortably, and they completely mix to form a clear solution or a clear matter picture. So I would say that if you move throughout the matter, then you would see that every point in the matter has the same concentration, and inside the bulk, the composition remains uniform. The very obvious example would be sugar solution, a clean solution where there is no decomposition of extra sugar. Okay, if you take that sugar solution, then it would be uniform and hence will be classified under homogeneous mixture. The same thing can be said for air. But in the heterogeneous mixture, the composition is not uniform, and sometimes different components are visible. Now, for this example, you can take a mixture of salt and sugar. So, if you take a mixture of salt and sugar, you will see that the composition of salt and sugar would never be, and it is it is really not possible to make a homogeneous mixture of out of these two solids until and unless they are converted into a liquid phase. So, for example, the mixture of salt and sugar, or you can take the example of grains and pulses mixed together with along with some dirt. So that would be a good example of heterogeneous mixture. Now, if I talk about the segregation of the mixture, components of the mixture, then in case of heterogeneous mixture, it can be done by physical methods. So you must have seen your mother picking up the dirt from the grains. So that is a very simple example of segregation of the components of the mixture, which is called as hand picking. Or you can think about the filtration of water, which is again a process of separation of the dirt particles or the unwanted substances from the water. Next is crystallization or distillation. So they all are the example of removing of components of the mixture. So you can separate the homogeneous or and heterogeneous mixtures both. So distillation can be used, or the crystallization can be used to remove the components of homogeneous mixture. So if you start heating a sugar solution, the water will get evaporated and the sugar will be crystalled out. Now, pure substance have characteristics different from mixture. So constituent particles of pure substances have fixed composition. So now we are talking about the characteristics of pure substances. It is being said that if you take a pure substance and form a mixture, then the pure substance has a different property as compared to the mixture. Also, the constituent particles of pure substances have fixed composition. Examples of pure substances would be copper, silver, gold, water, glucose. Then, glucose contains carbon, hydrogen, oxygen. These three atoms have individually completely different property as compared to the glucose. But if they are taken in a fixed ratio, they form glucose at a given composition, which is C6H12O6. So we can say that glucose is a pure substance as it has a fixed composition of these three atoms. Now, if I try to remove the carbon, hydrogen, and oxygen from glucose by physical methods, then it is near to impossible or it is never possible. Now, let us talk about the classification of pure substance. We have talked about the classification of mixture into homogeneous and heterogeneous. Here we will try to classify pure substances, elements, and compounds. So, what is the meaning of element? So, elements are those matter which have the same particle, okay, or the same type of atoms present inside. Now, these particles may exist as atoms and molecules both. Now, remember this point that particles of a pure substance can be atoms or molecules both, but it should have the same atom inside it. Example would be sodium, copper, silver, hydrogen means H2, oxygen O2. So all these are examples of what? Elements. Now why are they called elements? Because their constituent atoms are same. In case of hydrogen, which is H2, they all have hydrogen atom. Similarly for oxygen, we have the oxygen atom. Some elements such as sodium or copper contain atoms as their constituent particle. Whereas in the other, we have molecules as the constituent particle, but the atoms are same. As I told you, hydrogen or nitrogen, oxygen gas, they all consist of molecule in which two atoms are combining and these two atoms are identical. Coming on to the representation of atoms and molecules. So here is a representation of hydrogen atom, oxygen atom, nitrogen atom, copper atom, and sodium atom. Out of these five, the isolated form of copper and sodium can be observed, or you would say that in a bulk of the copper, you would see copper atom present as a single entity, and same thing can be said for the sodium. But for the case of hydrogen and oxygen, it is not possible. So, two hydrogen atoms come together to form a molecule with the help of a bond. The molecule that is being formed is the hydrogen molecule, written as H2. Okay. So we have a hydrogen atom here. We have a second hydrogen atom here. These two are combining to give us a hydrogen molecule. Now, this is an example of an element. I am trying to convey the message to you that it is not that every molecule is a compound. Okay. So remember, again I am repeating it, element can be both atom or molecule, but in the molecule part, the atoms should be same. Like this one, the atoms are hydrogen. So if you are taking 1 liter of hydrogen gas, okay, then in that you will have only and only hydrogen atom present that are combined and there as hydrogen molecule. Now the same thing can be done with the help of oxygen atom. So you take two oxygen atoms, combine these two to form an oxygen molecule. Now, if I ask you what is their motive behind forming a entity like this, which is O2 or H2. So to answer this, we will have to move to the chapter chemical bonding. So I will cover this chapter in the upcoming lectures. So I'm giving you a hint here. You must have studied in the previous classes, or if you have not studied, no problem. We will see the same thing in the chemical bonding. So there you would see that the oxygen atom itself is unstable due to a incomplete configuration or an incomplete octet. So to get that octet or to get 8 electrons in their valence shell, 2 oxygen atoms are coming and combining together to give this O2 molecule. Okay. But in case of hydrogen, they form a duplet. Okay. Duplet means in case of hydrogen, we have the first shell only, and the first shell can occupy a maximum of 2 electrons, which is getted from this hydrogen atom, the other hydrogen atom. Okay. So here they are not forming a octet, they are forming a duplet. So this case is only true for hydrogen and helium and lithium. I hope you are getting my point about what is an element. So all of these are elements here. Now, when two or more atoms of different elements combined in a definite ratio, then the entity that we get is called as a molecule of compound. So now we have a molecule of compound. Initially, we were discussing about the molecule of an element. Now, again, in pure substance, we cannot remove or we cannot segregate the constituents of a compound with the help of simple physical methods because they have a very strong bond between them, and to break the bond we need a very large amount of energy. They can only be separated with the help of chemical method. One of the example of chemical method is electrolysis of water, which gives, or not the pure water, the salt solution, which gives us hydrogen and oxygen gas in a separate chamber. Similarly, same thing can be done for ammonia, whose formula is NH3, which has 1 nitrogen atom and 3 hydrogen atom for 1 molecule of ammonia. In carbon dioxide, we have 1 carbon atom and 2 oxygen atom. And in sugar, we have 12 carbon atom, 22 hydrogen atom, and 11 oxygen atom. So these all are example of compounds which are molecules formed from different atoms. So we can consider them under the example of compounds. Let us try to represent the water and carbon dioxide in the same way we have represented our H2 and O2 elements. You can see here we have an illustration of water molecule. Here we have 2 hydrogen atoms which are getting combined to a central atom, which is oxygen, to form a water molecule. The ratio of hydrogen is to oxygen would be 2:1. So this is the ratio of the number of atoms. Then if I talk about carbon dioxide, again we have carbon in the middle and oxygen on the either side. Now you can see a clear difference in their structure, although these two compounds are triatomic. Triatomic means these two contains 3 atoms. But the arrangement is different. The hydrogen here is present in an angular form. So this is an angular form. Whereas in a carbon dioxide, we have a linear type of structure. Okay. So we will study about this also in the chemical bonding chapter, that why is the structure different for the same number of atoms but different atoms. As I have told you, that water molecule can be represented with the help of two hydrogen atoms and one oxygen atom. Similarly, a carbon dioxide can be represented with the help of two oxygen and one carbon. What is the common thing between these two? The common thing between these two is wherever the water molecule is present, it doesn't matter whether the water is from the river or it is from the tube well or it is from the tap, all the constituent molecule will have this same structure and same number of hydrogen and oxygen atoms. Okay, the one molecule would be having a same composition, and this thing is true for carbon dioxide also. So we can say that for a compound, the number of atoms is always fixed and is in a definite ratio, and this ratio is the characteristics of a particular compound, as this ratio cannot be replicated for any other different substance. So if you are saying that we are taking two hydrogen and one oxygen, then it will form only and only water. Okay. Yes, it may be possible that we can get a different isomer of the same compound. Yeah, that is also possible. But in the case of water, it is always two hydrogen and one oxygen. Now again, I am repeating it. It is possible that if we take same number of atoms, then we can form a different compound. Okay, I am not denying from it, but still it is a characteristics of the particular compound. So the properties of a compound are different from those of its constituent element. So you know it very well that if you take the oxygen molecule and see its state, then at normal temperature and pressure, it is gaseous in nature, whereas this water molecule is liquid in nature, okay, in its standard form. So we can say that upon changing the or upon combining two or different atom, we get a completely different type of molecule, okay, which is having no resemblance to its constituent element in the terms of physical and chemical properties. Example, hydrogen and oxygen, which are the constituents of water, are gases in nature, whereas the compound which is formed is water as a liquid state. So this was all for today's class. Okay, I hope you enjoyed the lecture.